Alright, well, a funny thing just happened as I recorded this video. I'm in the new further out position, trying it out, see if being further away makes my penmanship better. It seems to have, and I just get ready to record the thing, set it aside. And believe it or not, with all my high-tech chicanery, I didn't turn the microphone on, so it would have been just would have been a silent movie. And we were trying not to do a silent movie, try to do one that works. So, topic: antiderivatives with the inverse trig functions. So let's have at it. The green light's on, so I know I'm recording. The antiderivatives of the inverse trig functions, and they're not the antiderivatives, the inverse trig functions. They're the antiderivatives that lead to the inverse trig functions. They take one of these three forms. Okay, we've got a constant squared minus a variable squared. In the arc sine version, it's arc sine u over a. If we have a constant squared plus the variable squared, that leads us to the arc tan format. And if we have a variable outside and then we have that variable squared minus the constant squared and the square root, then that leads us to the arc secant. Okay, notice that two of the forms have the 1 over a out in the front, 2 out of the 3. How do we remember which ones have the 1 over a? Well, here's how. See how tangent has an a in it? It gets the 1 over a. Secant, on first glance, doesn't appear to have an a in it, but if we spell it all out, secant has an a, so it gets the 1 over a. And finally, sine, no matter how we spell it, doesn't have an a in it, so we don't have to worry about the sine getting the 1 over a. So if the function, the arc function, has the letter a in it, the inverse the antiderivative gets the 1 over a part. All right, let's play with these, see what happens as we move forward. Okay, it's looking like, if you can look at your forms, I've got a constant squared minus a variable squared, so this is going to turn into an arc sine situation. Okay, we just need to identify what u is. U is x, du is dx, and a is 2, square root of 4. Okay? So we know it fits the arc sine format, so we just go right ahead with it, and it turns out to be the arc sine of x over 2 plus c. Done. Okay, identify what u is, identify what a is, fill in the puzzle. Okay, to identify the form, fill in the puzzle. It's that simple. Here we go. What are you thinking for a form? Hopefully you thought arctan. Okay, so it's an arctan because it's a constant squared plus a variable squared. And if it was 9x squared plus 2, that's the same thing, right? So u in this case is going to be 3x, because 3x times 3x is 9x squared. That means du is 3 dx. And a is, well, the square root of 2. I'm going to sneeze. Sneeze 3 times. Shut the thing off so you don't have to hear it in your headphones. And the mic's back on. So we just go with the format. It's fitting the thing. We just need to put a 3 in. Take a 3 out. Okay, so the 1/3 is going to come along for the ride. And then we just do the format. And it's arctan, which has an a in it. See the a right there? So it has the a, so we're going to get 1 over a, which is 1 over root 2. Arctan u over a, which is 3x over root 2. Plus c. Simplify that, it becomes 1 over 3 root 2 arc tan 3x over root 2 plus c. I think my writing's a little better. I'm a little further back. We'll see what you think when you look at this. Continuing. Anyone guess that the next one was going to be an arc secant? You were correct. Okay. So u in this case is the square root of 4x squared. 2x, because 2x times 2x is 4x squared. A is 3. And du is just 2 dx. Okay? I don't have a 2, so I'm going to put a 2 in. And here's how I'm going to take the 2 out. I'm going to take the 2 out right there. Okay? Reason being, because I want, for arc secant, I want the format to be du over u square root of u squared minus a squared, right? So when I do that, this right here is u, which is what I need. This right here is u squared, which is what I need, and this is a squared, which is what I need. Okay, so I've got everything I need. So I don't always do like hokey pokey in and out. If I can make it work to my advantage to get it to be a form that I like, then I'll go with it. Okay, we're heading towards an arc secant. Ooh, up in there. Heading towards an arc secant. And so with the arcsecant, I need the 1 over a out front, so that's 1/3. And I need u over a, which is 2x over 3 plus c. And I believe I am done with that particular one right there. If I took the derivative of 2x, of this function, I'd get the thing that we started out with. I really would. So bear that in mind. I can always check all these antiderivatives by taking the derivative and making sure it gets me back to where I wanted to be. All right, what are you thinking about this one? This one could maybe go either way. It looks initially like it might be a sine, right? Because I've got variable in one. I don't have anything out here, but it's not in the order of the arcsine. Arcsine has the constant minus the variable. So let's see what happens. U is e to the x, okay? Because remember, e to the x squared is e to the 2x. Du then is going to be e to the x dx. And a, by the way, is 1, so that's good. All right, so I don't have e to the x dx, so I'm going to make it e to the x dx. Can I do that? I can, if at the same time I get rid of it by the bottom. So e to the x divided by e to the x within the integration sign, within the integral, is perfectly legitimate because I haven't changed anything. Okay, if I go through now and just do the full substitution, just so you see what I did, e to the x dx, that's du. Okay, on the bottom, I've got e to the x, which is what u is, and then I've got the square root of u squared minus a squared, right? So that's my arcsecant formula. And so for the arcsecant, I need 1 over a, which is 1 over 1, arcsecant, u over a, and u is e to the x over 1, plus c. And we would never leave this as a final answer because it's just ridiculous. 1 divided by 1, we know all those things. So this just turns into be the arcsecant of e to the x. Make it crazy e to the x one of these times. Yeah, that's so. E to the x plus c. And we're done. And again, take the derivative of that, and you'll get the original thing we started with. All right, I think we got one more. So let's try this one. What's u? What did we square to get this? T squared. What's du? 2t dt. What's a? 1. We have 2t dt? No, we just have that, so we'll do a 2 in, we'll do a 2 out. This is looking an awful lot like the arc. That's right, sine. So the half's coming along for the ride. We don't need a u over a because we're going to go arc sine, or 1 over a, I'm sorry, because we're going to go arc sine. Sine doesn't have any a's in it. And then we're just u squared over a squared, which is u squared is, u over a, I'm misspeaking, is u is t squared, and then over 1, so we're not going to bother with the over 1, plus c. 1/2 arc sine t squared plus c. Okay? So, there's that. Spinning homework assignment. Get back to that and that. And we'll just go back to the beginning format of these problems. Okay, everything's about finding the pattern. Does it fit the pattern or does it not? If we can make it look like one of these, then we can integrate it. If we can't, and we can't make it look like something we already know how to deal with, then we can't integrate it. It's all about the patterns. Okay? Thanks for watching. Hope you learned something. If you have questions, please feel free to ask me tomorrow. And we will talk to you then. And, hey, we did this in about 30 seconds less, so I should just vamp. No, I'll just say thanks for watching. Hope you learned something. See you tomorrow. Bye-bye.